In this brief video, we'll look at how the hygrothermal effects affect the stresses in the laminate. So earlier we have already discussed about how both the temperature and humidity affect stresses in the laminate. There we mentioned that the total strain in the lamina is a summation of the mechanical component of the strain and the strain coming because of temperature. Because of temperature, we said there is a CT effect, coefficient of thermal expansion alpha times delta T will give us the strain in thermal strain. And then similarly, we said because of the moisture, the water concentration increases in a lamina, and that also brings in a strain which we call it as the hygro strain or the moisture strain. So here we said the total strain is just a sum of these three strains. Later we replace this mechanical strain by writing in terms of the compliance matrix times the stresses. And we replace these thermal strains with coefficient of thermal expansion alpha times delta T, the change in temperature. Moisture strain, we wrote it in terms of coefficient of hygroscopic expansion times the concentration C. So, but from this expression, if we have to find the stresses, we can use the same expression and take the stresses to the left hand side. Then what is remaining is we have the inversion of this compliance matrix, which we wrote it with this stiffness matrix or the transform stiffness matrix Q bar times this total strain minus the alpha delta T minus beta C. So this should give us what are the stresses in a lamina. But now let's see how we can use this expression to develop the hygrothermal stresses in a laminate. So we'll use the same expression in the next slide. The only difference is here I am focusing it on a kth layer. So since I am focusing on a kth layer, I have used this subscript k, meaning that we are talking about stresses in the kth layer is given by stiffness matrix of the kth layer times the difference in the total strain minus thermal strain and uh, moisture strain. Okay. So from this, let's see how we can get to the laminate level. Meaning, first we'll start with N, which are the forces. We start with the definition of forces N. So in the earlier videos, we showed this N is given as integral of stress times dz. In this integral, we will substitute the stresses value from the first equation. And the only difference we made is we have substituted this strain with what we have learned for the strain variation in a laminate. So here we said it is written in terms of mid surface strains plus z times curvatures. So this should take care of strains at any across the thickness of the laminate. So from this expression we will again use small notations. So we'll first say what are the forces coming because of temperature. This will write it as integral qk alpha delta t. And similarly, the forces because of moisture we'll write in a similar integral form where it is q times beta for the kth layer times c. So once I and with dz. So with these definitions, I should be able to simplify this equation further. Now this force N is given in terms of this A matrix and the B matrix because Q times dz will give you the A matrix and B matrix we are getting from Q times the Z term here times dz. From there we get the B matrix. And Nt and Nm I just showed you where we go. So this expression can again be rewritten because once we move all the forces to one side of the equation, we can write it as N plus the forces from temperature coming from the forces from the moisture. This sum can be written as A times the strains in the mid surface plus B matrix times the curvatures K. So here we have shown what is the relation between the forces with the matrices A and B in terms of the strains at the mid surface and curvatures. Now let's do the same for moments. So moments, again we start with the definition of moment. Let's say these are stresses times Z dz, and in this expression again we use the first equation to substitute, and like last time we have substituted this epsilon with epsilon naught plus Z k. So this should take care of the strains across the thickness of the laminate. And here too again I can come with few definitions. So the movements because of temperature is written as q times alpha k delta t times z dz. So here is the z dz. That's the difference between the moment and the force. And similarly we can also write it for the moments because of the moisture in a similar fashion. But let's see how this simplifies this last equation. Now I can write this moment in terms of the B matrix and the D matrix, as well as these movements coming from temperature and movement coming from moisture. And like earlier I can move these movements all to the left hand side, then it becomes movement plus movement because of temperature plus movement because of moisture can be written in terms of the B matrix times the mid surface strains plus D matrix times the curvatures. So these two equations which I have shown in the boxes, these are the modified classical laminate theory equations, where now we have accounted for the temperature changes as well as the moisture changes. Probably we haven't mentioned it earlier. Here we are only accounting for changes because of temperature. We are not accounting to the changes in the mechanical properties because of temperature. Because sometimes if the temperature changes are high, even it might affect the values of alpha. It might also affect the stiffness of these layers as well. But for this discussion, to keep it simple, we have assumed that the mechanical properties don't change. The only changes are these thermal strains and the moisture strains. And this should give us a neat expression to relate the forces with the strains, mid surface strains and curvature, and movements to the mid surface strains and curvature. So with this, let's conclude this video, because here we have seen how the hygrothermal effects change the stresses, the strains, as well as the forces and moments. Okay, thank you.